This video is on geometry of linear systems. So for instance, if we want to calculate the area of a parallelogram, which looks like this if you remember, what we're going to do is we are going to take the norm of a cross product between V and W. So here you're given 4 points. You have the coordinates for A, B, C, and D, which are written out right here. A is going to be this corner, B is this corner, C, and then D. So I said that my vector v is going to be the line between A and B, and my vector w is going to be the line between A and D. Now to find it, I'm going to take B minus A, so all my coordinates of B minus all the coordinates of A is going to equal my vector v. To do that, I take 1 minus minus 3, because here B is 1, A is minus 3, so 1 minus minus 3 is equal to 4. Minus 5 minus negative 2, taking my y's, is equal to negative 3. And then 4 minus 4 is equal to 0. And this is my vector v, so from A to B. Now I do the same thing from A to D. I take my values of D minus my values of A. So here I have minus 4 minus minus 3, which is equal to negative 1. 2 minus minus 2 is equal to 4. 0 minus 4 is equal to negative 4. So I figured out what V is, I figured out what W is, and now I'm going to take the cross product between them. If you don't already know how to do that, the last video was just about the cross product. So if we remember, we're going to put our vectors into matrix form, like so, with our i's in one column, j's in one column, k's in the other. And to find out what the value of I is, we are going to cross out its column, cross out its row, and take the determinant of what's left over. So in this case, the determinant of minus 3 is 0, 4 minus 4, which is equal to negative 3 times negative 4, which is 12, minus 4 times 0. So my value of I hat is equal to 12. Now for j hat, I'm going to cross out this column in this row, and I'm left with 4, 0, 4 minus 4. I do 4 times negative 4, which is negative 16, minus 0. But remember, when we are finding the cross product, our j that we find is negative j hat. So we're going to have to multiply our answer by negative 1, and we get 16. For k hat, same thing. We cross out its column, and we cross out its row. We're left with 4, negative 3, negative 1, and 4. 4 times 4 is 16, minus 3 times 1, which is 3. 16 minus 3 is 13. So now that we have figured out what v cross w is, which is 12, 16, 13, we can figure out what the norm of that is. To find the norm, we're going to take each individual component, square it, and then take the square root of all of that. Again, if you're not too sure what the norm is, go back to a past video and make sure you really get that. So here my answer is the square root of 569, and what I just figured out is the area of that parallelogram. Now to find the area of a triangle, it's actually really simple. We do exactly what we just did, and we divide that answer by 2. So if I were only to be given the 3 points of a triangle, it would be as though I were to be ignoring this C and just drawing a line from B to D, and that would be my triangle. You can see that we do the exact same thing, but our answer would just be cut in half as well. Now this one's quite a bit trickier. We're trying to find the volume of a parallelepiped. So what that is, it's this type of shape where each side is its own parallelogram. And to find its volume, what we do is we take A dotted with the cross product B to C. But you're not going to just be given 3 points. Sometimes you might be given 4 points. So here we are given Q, R, S, and T, where Q is this point, so it's this bottom left-hand corner, and T is way up here, S is down here, and R is down here. With this information, we can figure out the length of A, which is going to be from Q to T, so it's this line up here. We can figure out what B is, which is this side down here from Q to S. And then we can figure out what C is, which is from Q, so this corner, to this corner down here. Now the same thing as last time. To find out what A is, we're going to take the values of T, so this top left corner, minus the values of Q. Here we do that. So we have A is equal to 9 minus 5, because T, 9, Q is 5, so 9 minus 5. Y is 4 minus 4, because 4 here minus 4 here. and then z is minus 4 minus negative 4. So vector A is equal to 4, 0, 0, and that is this side. Now for B, we do the same thing, but it's between the points S and Q. So S minus Q, so negative 1 minus 5, which is negative 6, 7 minus 4, which is 3, negative 5 minus negative 4, which is negative 1. Lastly, for side C, we take our point R minus our point Q. So 6 minus 5, which is 1, 9 minus 4, which is 5, and negative 1 minus negative 4, which is 3. Remember, this is the formula we're using. So we have V, our volume, is equal to A dot B cross C. We know what A is, we know what B is, and we know what C is. So we can just go ahead and find the cross product between B and C by putting these two vectors into a matrix where the first column is I, second is J, third is K. We do that, and to find I, we cross out I's column and I's row, and we find the determinant of what's left over. So 3 times 3 is 9, minus negative 5 is 14. Now for J, we cross out its column and its row, find the determinant of what's left over. Negative 6 times 3, negative 18, minus negative 1 is negative 17. Remember, the J hat is negative, so we have to multiply our answer by negative 1, and we get 17. K hat, we get rid of its column and its row, and we find the determinant of minus 6, 3, 1, 5. Minus 6 times 5 is negative 30. Minus 3 is negative 33. So we figured out what B cross EC is. The last thing we're doing is finding out what A dot that answer is. So now we have our two vectors left over, and to find the dot product, if you remember, we multiply our x's together, plus a multiplication of our y's together, plus our multiplication of our z's together. So 4 times 14 plus 0 times 17 plus 0 times negative 33, and our answer is 56. So we just figured out what the volume of this parallelepiped is using 4 coordinate points.